India just opened the widest road tunnel on Earth. India just punched a hole through a mountain, and what came out the other side broke a world record. Not just any mountain, the Sahyadri Range, a rugged, misty wall of rock that has blocked one of the world's busiest trade corridors for many years. And on one side, Mumbai, India's financial capital. On the other, Pune, a booming tech hub that, together with Mumbai, forms one of the biggest economic engines in South Asia. And for years, the only road connecting them was a nightmare. Let me paint you a picture. Imagine you're driving from Mumbai to Pune. The distance between these two cities is about 150 kilometers, not far. For the first half of the drive, everything is smooth. The Mumbai-Pune Expressway is modern, well-maintained, and fast. You make good time. And then you hit it. The Ghat section. Near the hill towns of Kandala and Lonavala, the expressway effectively ends. The road narrows. 4 lanes become 2. The gradient steepens. Blind corners appear around every bend. Suddenly, you're not on a highway anymore. You're on a mountain road that feels like it was built in a different era. Because in many ways, it was. This stretch, just a handful of kilometers long, was one of the most dangerous sections of road in India. Accidents happened regularly, predictably. Vehicles would lose traction on the wet surface during monsoon season. Drivers would misjudge corners in the thick mountain fog. One incident, a single overturned tanker, one accident blocking a lane, could lock up the entire corridor for hours, sometimes over a day. The expressway carries around 75,000 vehicles every day. On weekends and holidays, that number touches 120,000. When one thing goes wrong in that Ghat section, the pain spreads across both cities simultaneously. And the economic damage? Enormous. Every hour that freight sat motionless was an hour of goods not reaching factories, of supply chains grinding to a halt, of contracts missed. For a corridor connecting 2 of India's most productive cities, the cost was staggering. India knew for decades that something had to change. The question was what, and whether anyone could actually build it. Here's the strange part. The Mumbai-Pune Expressway was actually a landmark achievement when it opened in 2002. It was one of India's first modern limited-access highways, a genuine step change for a country where road travel had long meant grinding through city traffic and crumbling national highways. But even as it was being celebrated, engineers knew the route had a structural flaw. Right where the road had to cross the Sahyadri Mountains, there was simply no good surface solution. The terrain was too steep, too unstable, and too ecologically fragile to simply widen the road. So the expressway opened, and that section was left unresolved. A modern highway with a weak link built into it from day one. Over the following 2 decades, as Mumbai and Pune both grew rapidly, as more vehicles flooded onto the expressway, as India's manufacturing and technology sectors exploded along this corridor, that weak link got weaker and weaker. By the time planners sat down seriously to solve it, they weren't just fixing a road, they were trying to rescue an entire economic artery that was slowly being choked. The solution they landed on wasn't about going around the mountains or finding a longer alternative route. It was about going directly through them. The project got its name from exactly what it was: the missing link. The piece of infrastructure that should have existed from the start and didn't. The plan: build a series of twin tube tunnels directly through the Sahyadri mountain range, bypass the Ghat section entirely, cut around 6 kilometers off the journey, save drivers 25 to 30 minutes every single trip, eliminate the narrow, accident-prone mountain road that had caused so many deaths and so much economic disruption. On a map, it sounds almost simple. 2 cities, 1 mountain range, a straight line underneath. The total corridor tunnels, viaducts, connecting road would stretch 13.3 kilometers, replacing an existing 19-kilometer winding mountain route. The longest tunnel bore alone would run 8.92 kilometers through solid rock. In practice, this was one of the most technically demanding infrastructure projects India had ever attempted. The Sahyadri Mountains are not kind to engineers. The geology here is layered basaltic rock, hard in some sections, fractured and unpredictable in others. There is significant groundwater running through the range, and the project passes directly beneath Lonavala Lake, a body of water sitting above the tunnel line, creating constant pressure management challenges throughout construction. Above all this, the Western Ghats receive some of the most intense monsoon rainfall anywhere in Asia. That rain doesn't stay on the surface. It seeps into the rock, shifts pressure dynamics underground, and can create sudden, dangerous changes in conditions mid-construction. The method used throughout this project was NATM, the new Austrian tunneling method combined with carefully controlled blasting. This approach involves excavating rock face by face using explosive charges placed with precision then immediately securing the exposed tunnel walls with steel reinforcement and sprayed concrete to prevent collapse before the permanent lining goes in. It is slower than machine boring. It demands constant expert assessment of rock conditions, and it requires an extraordinary level of discipline because the margin for error underground, beneath a lake, through fractured mountain rock, is essentially zero. Thousands of workers rotated through the site around the clock, over 9 million man-hours in total. More than 85 lakh tons of rock were excavated. 7,600 tons of steel went into the structure. The project also required building viaducts 180 meters high across a valley, using ultra-high performance concrete to span terrain that would have been impossible with standard methods. And throughout all of this, the engineers were building to a specification unlike any tunnel in the world. Because the bores they were carving weren't narrow passages, they were vast underground chambers over 22 meters wide. To understand how extraordinary that is, most major road tunnels globally are designed to do the minimum, get vehicles through safely, with as little excavation as possible. Every additional meter of width underground means exponentially more rock to remove, more structural load to manage, more complex engineering to execute. This tunnel went over 22 meters wide, through a mountain, through fractured basalt, beneath a lake. There's a reason no one had done it at this scale before. When the tunnel was complete and the measurements independently verified, the project team applied to Guinness World Records. The Guinness team conducted their own survey. 3 months later, the result was confirmed. The Mumbai-Pune Missing Link Tunnel is the world's widest underground road tunnel, with a certified width of 22.33 meters. The record was presented to Maharashtra Chief Minister Devendra Fadnavis at the inauguration on May 1, 2026 Maharashtra Day, in front of the tunnel entrance that had taken 7 years and billions of rupees to reach. In a world where China is building artificial islands, where Saudi Arabia is constructing a straight-line megacity in the desert, where the US is pouring hundreds of billions into infrastructure renewal, India quietly built something that none of them hold. A Guinness World Record that belongs only to this tunnel. And the recognition matters beyond the trophy. It is external confirmation from an independent global body that what India engineered here is, by any international standard, genuinely unprecedented. The missing link opened on the 1st of May, 2026, and the immediate impact was visible. Light vehicles and passenger buses, the first category cleared to use the tunnel, began flowing through. The journey that used to mean crawling through the Ghat section now takes minutes underground, at speeds of up to 100 kilometers per hour, in a fully lit, fully ventilated, CCTV-monitored tunnel. But here's an important nuance the headlines glossed over. Heavy goods vehicles are not yet using this tunnel. Indian safety guidelines permanently ban hazardous cargo vehicles from tunnel use. And heavy goods vehicles more broadly are restricted from the new tunnel until at least the end of October of 2026, while authorities monitor traffic flow and safety systems during the first operational months. This matters because freight movement was one of the biggest arguments for building the tunnel in the first place. The full economic unlock for supply chains, for manufacturing, for the movement of goods between two of India's most productive cities won't be complete until heavy vehicles are cleared to enter. What's already changed is real though. The Ghat bottleneck that could paralyze the corridor for an entire day no longer has the power to do that. The single point of failure, that narrow mountain road, has been bypassed. And over time, as the tunnel fully opens to all vehicle types, the 5 to 3 0-minute time saving per trip, multiplied across 75,000 vehicles a day, will compound into an economic impact that economists are only beginning to model. Here is where this story gets bigger than one tunnel. India is in the middle of the most ambitious infrastructure expansion in its history. Highway construction has been running at rates that rival China's most aggressive expansion phases from the 2000s. New tunnels are being bored through the Himalayas to connect regions that were cut off for months every winter. Metro networks are being built in cities that had no rapid transit 5 years ago. Ports, airports, and freight corridors are being upgraded simultaneously across a country of 1.4 billion people. The missing link sits inside this national push, but it also stands apart. Because this isn't India catching up to global standards. This is India setting a record that no one else in the world holds. Demonstrating tunneling and underground construction expertise that places Indian engineers in a category they have not occupied before. For decades, India's infrastructure was often the punchline in economic discussions. Great potential, terrible roads, brilliant engineers, crumbling highways, the missing link completed, Guinness certified, fully operational, is a data point that belongs in a different conversation entirely. But a story this big always has more than one angle. The missing link took significantly longer than planned. Originally targeted for March 2024, the project missed 4 deadlines before opening in May 2026, 2 years late. The final cost landed at around 6,700 crore rupees, a figure that will be scrutinized as India accounts for the full bill. The Western Ghats, through which this tunnel passes, is not just a scenic backdrop. It is one of the world's 8 recognized biodiversity hotspots, a UNESCO World Heritage Site, home to thousands of plant and animal species found nowhere else on Earth. Tunneling through this landscape, at this scale, drew serious concern from environmental groups throughout construction, and long-term ecological monitoring of the project area remains an ongoing conversation. And then, there are the communities. The villages that live in and around the Ghats watched this construction reshape their landscape over 7 years. Major infrastructure projects almost always promise broad economic benefits. How those benefits actually distribute versus how the disruption of construction concentrated is a question that local residents are better placed to answer than government press releases. This tension is real, and it is not unique to India. It lives at the heart of every mega project anywhere in the world. The question is never just, can we build it? The deeper question is always, who does building it actually serve, and what did it cost to serve them? What is certain is this: the tunnel is built, it works, it holds a world record, and the debate about what it truly cost in every sense of that word is far from finished. India built the widest underground road tunnel on Earth, through a UNESCO World Heritage mountain range, beneath a lake, using 9 million man-hours of human effort, and Guinness made it official. But here's the question that keeps engineers and planners up at night. The Mumbai-Pune corridor handles some of the heaviest traffic in Asia, and that traffic is growing. The full opening of the tunnel to heavy freight is months away. The economic ripple effects of this project are still unfolding, and India's infrastructure ambition does not stop here. The next phase of projects being planned along this corridor and across the country will make this record-breaking tunnel look like the opening move in a much larger game. That story, the full picture of what comes next, we will tell it. If this kind of deep-dive storytelling is what you come here for, the real economics, the engineering, the geopolitics behind the world's biggest projects, then consider supporting this channel directly. Every contribution helps us go deeper, research harder, and bring you stories that most channels won't touch. The link to support is in the description below and in the pinned comment. Even a small donation keeps this work going. And if you are not in a position to contribute right now, sharing this video with someone who would find it interesting does exactly the same thing. Thank you for watching. We will see you on the next one.